السلام عليكم ورحمة الله وبركاته. In this section, we are going to speak about curves defined by Euler equations, how to sketch the graph, and we will have two methods to solve to sketch the graph sometimes, and sometimes only one method. When we speak about graph using parametric equation, there will be a curve and there will be a direction of the curve. Now, let's start our first question. Here we say sketch the graph of t cubed plus t, okay, and y equals to t squared plus t from minus 2 to 2. So if we select the points of t to be starting with minus 2, then minus 1, then 0, 1, and 2, we will calculate the value of x. If we substitute minus 2, we get minus 8 plus 2, which is, if we substitute minus 2, we will get minus 8 with minus 2, it's minus 10. That is for x. For y, we will have, if we substitute here minus 2, you will get 4 plus 2, which is 6. Now, if we substitute minus 1, I'll get minus 1, and minus 1 is minus 2. If we substitute minus 1, will be 1 plus 2, which is a 3. Now, if we substitute 0 for x, I'll get 0, but for y, I'll get 2. And if I substitute 1, 2, if I substitute 1, I'll get 3. And if I substitute 2, I get 8, which is 10. And if I substitute 2, 4 plus 2, which is 6. So going to the xy plane, we started with x is minus 10. This is minus 1, minus 2, minus 3, 4, 5, 6, 7, 8, 9, 10, and 6, that will be 1, 2, 3, 4, 5, 6. That's the first point. Minus 2, and this is minus 2 and 1, 2, 3. Okay. And we have 0 and 2. Okay. Then we have at 2 it's 3, 1, 2, 3 again, and at we have at 1 it's 3, sorry, at 1 it's 3, and at 2 we have 1, 2, 3, 4, 5, 6. Okay. Sorry, it should be at 2 it's 3, and at 2 it's 3, 1, 2, 3, and at 10, so this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It will be 1, 2, 3, 4, 5, 6. So we started from here, going that way, and that is our graph. Same thing here. We do exactly the same thing. This is values of t. We will calculate x, and we will calculate y. Starting from minus 3, so that will be minus 2, minus 1, 0, 1, 2, 3. Now, if I substitute minus 3, I get here 2 raised to the power minus 3 minus 3. So that will be minus 3 and 1 over 8. Okay, so that will be at minus 3, it will be, when we substitute minus 3, it will be minus of minus 3, which is a plus 3, and 1 over 8. So it will be 3.125. 3.125. For the y coordinate, if we substitute minus 3, it will be 2 raised to the power 3 minus 3, so it will be 8 minus 3, which is 5. Now, if we substitute t is equal to if we substitute minus 2, we'll get 2 raised to the power minus 2 plus 2, which is 2 and 1 quarter, which is 2.25. If we substitute minus 2 here, it will be 2 raised to the power 2 minus 2, which is 2. Now, if I substitute minus 1, we will get, if we substitute minus 1, we will get 1 plus 1, so it will be 1.5. Okay. And if we substitute here minus 1, it will be 2 minus 1, which is 1. If I substitute 0, it will be 2 raised to the power 0 minus 0, which is 1. And if I substitute there 0, I'll get 2 raised to the power minus 0 plus 0, which is again 1. Okay, now if I substitute 1, I'll get 2 raised to the power 1 minus 1, which is again 1. And it will be 2 raised to the power minus 1 plus 1, which is 1.5. Then if I substitute 2, I'll get here 2 raised to the power 2 minus 2, which is 2. If I substitute here 2 raised to the power minus 2 plus 2, so that will be 2 and 2.25. Okay, and last, if I substitute a 3, it will be 2 raised to the power of 3 minus 3, so that will be 8 minus 3, which is 5. And when I substitute, it will be raised 2 raised to the power minus 3 plus 3, so it will be 3.125. These are the points. Now we go to the plane, xy plane. this is x-axis, that's y-axis. So we have x is a 3.125 and y is 5. So this is 1, 2, that's 3, and 1.25, and 5. This is 1, 2, 3, 4, 5. Then we have 2.25, 0.25, and 2. Okay. And then 1.5 and 1, 1.5 and 1. Then at 1, it's also 1. Okay. And then so we have at 1 also 1.5. Okay. And at 2, 2.5. This is 2 and 2.5, 2.25. Okay. And then at 3, it is x is 5. This is 1, 2, 3, 4, 5, and the 3. 1, 2, 3, 1, 2, 5. So the graph will be this way, and it will go that way, and it will go that way. So that's our graph. Here it says sketch the graph, indicate the direction which the graph traced. So we'll do the same thing. So we have to select a few points. Let's say t minus 4, then minus 2, 0, 2, and 4. We just selected a point. We will calculate x. We will calculate y. So if I select t is minus 4, we will get minus 12 plus 2, which is minus 10. And here it will be 2 times minus 4 is minus 8 plus 3, which is minus 5. Minus 2, I'll get minus 6 plus 2, which is minus 4. If I put minus 2, I'll get minus 4 plus 3, which is minus 1. If I put 0, it will be 2. If I put 0, it's 3. If I put 2, it will be 6 plus 2, which is 8. If I put 2 here, it will be 4 plus 3, which is 7. If I substitute 4, it will be 12 plus 2. If I select plus 3, that will be more than enough to sketch a graph. So we'll go to now. So what we have is this. We have minus 10x minus 5. This is minus 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Minus 5, 1, 2, 3, 4, 5. That's the minus 10 and minus 5. Minus 4, 1, 2, 3, 4, minus 4, and minus 1. We have 2 and 3. 1, 2, 3. Okay, 8 and 7. This will be 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. Okay, okay, that's here a straight line. And going to that direction. Okay. Now here it says eliminate the parameter to find the Cartesian curve. We can solve for from 1 and we get the value of t. We have x equal to 3t plus 2. So that will mean x minus 2 is equal to 3t, and we divide now by 3. So we get the value of t is equal to x minus 2 over 3. Now replace it in equation 2, which is y equal to 2t plus 3. So y will equal to 2 times t, which is we replace it by x minus 2 plus 3. So that will be y equal to 2/3 x minus 4 over 3 plus 3. So if we simplify it, that will be 2/3 x minus 4 over 3 plus 9 over 3. It will be plus 5 over 3. Now that is a straight line, and you can see if we select any 2 points, we will get the graph as well. If I select, let's say, x equal to 2, 1, 2, what I will get y. If x is 2, we'll get 4 over 3 plus 5 over 3, which is 9 over 3, which will be 3. So when x 2, we get 1, 2, 3. Okay, when I select x equal to, so what I have said, this is xy. I selected 2 and I'll get 3. Now let's select minus 2. What will happen? If I select minus 2, that will be minus 4 over 3 plus 5 over 3. That will be 1/3. Okay, if I select just simply minus 1 is easier. If I select minus 1, if x equal to minus 1, I'll get minus 2/3 plus 5/3, which is 3 over 3, which is equal to 1. So x equal to minus 1, it will be 1. So that will be same straight line we have there. And to select the direction, if we choose now t equal to choose t equal to 0, I'll get the value 2 and 3. So that will be 2 and 3, which is this point. If I select t is equal to, let's say, 1, I'll get 5 from here. Select t equals will be 5. So 1, 2, 3, 1, 2, 3, 4, 5, and 5. So we could know now the direction is that direction. So here we have two methods to sketch the graph, either the normal plotting by points, selecting values of t, then, or we change it to Cartesian system, then we sketch the graph. Same thing here. It says sketch the graph of this one from 0 to 2 pi. First of all, we know this has a period 2 pi divided by b, but b is 1 now for cosine and for sine, so it would be 2 pi over 1, which is 2 pi. And we get the increment delta, which is period divided by 4, which is 2 pi over 4, which will be pi over 2. This will help me to find the values of t, the key points, select the key selection point. We will start with 0, then delta, which is pi over 2, then pi, then 3 pi over 2, and we end up with 2 pi. Be careful if you use your calculator to put it in radian. This is t, that will be x, and that will be y. But for me, I will use the unit circle. The unit circle says this is 1, 0, this is 0, 1, minus 1, 0, 0, and minus 1. So if I want to select x now, and of t is 0, sine 0 is 0, sine pi over 2 x 1, and sine pi is 0, 3 pi over 2 is minus 1, and cosine 2 pi is 0. So for sine, that's the values of sine. 0, 1, 0, minus 1, then goes back to 0. Now for cosine, when t is 0, cosine 0, it will be, cosine 0 is 1, and 1 minus 1 will be 0. Then it will be 0, so that will be what? 1. At pi, it is minus 1, so 1 minus of minus 1, it's 2. And at minus, it will be 0, so that will be 1. And at 2 pi, it will be 1, so 1 minus 1, which will be 0. So now, when we sketch the graph, what we will get, when we sketch the graph in the xy plane, now we have the first point is 0 and 0, which is this point, and we have 1 and 1, and then we have okay, this will okay, so this is 1, that's 2, okay, and we have minus 1 and 1 again, then it will be 0. So the graph is this one. Now, we started with 0, 0, then we go to 1, 1, so it will be anti-clockwise. Anti-clockwise. Another way to sketch the graph, we have x equal to sine t, and we have y is equal to 1 minus cosine t. So we can say this one can be written as cosine t is equal to 1 minus 1. Okay, so we know to x squared plus 1, sorry, x squared plus y squared, that will be equal to, uh, sorry, I should say we have in math 2 sine squared plus cosine squared is equal to 1. And what is sine is equivalent x, so it will be x squared. And cosine is equivalent to 1 minus y squared, and that should be 1. That is equivalent to say x minus 0 all squared plus y minus 1 all squared is equal to 1. This is circle centered at 0 and 1. So when we draw the circle, centered at 0 and 1, so from each direction 1 unit, 1, and 1 unit here, 1 unit there. So our graph will be same circle. And the direction, as I said, to know direction, we should start when t equal to 0. We will get 0 and 0, which is this point. When I choose 0 to be pi over 2, I'll get sine pi over 2, which is 1, and cosine y over 2, it will be 1. It will be 0, so it will be 1 and 1. So that will be 1 and 1, which is this point, so the direction will be anti-clockwise. That's the way we calculate. So we have two methods to solve here. Here, again, I have to remind you about when we say x or y is equal to a cosine bx, or whenever we have y is equal to a sine, or yeah, sine bx. Here we have period, first of all the amplitude, which will give me the height, which is absolute value of a, which, okay. Then we have period, it's 2 pi divided by b, okay. In our case here it will be 2 pi over 4, which is pi over 2, okay. And delta, it's period divided by 4, which is period is pi over 2, so it's pi over 2 divided by 4, it will be pi over 8. So our key points will be the values of theta. We will select first 0, then pi over 8, then 2 times pi over 8, then 3 pi over 8, and 4 pi over 8, which is pi over 2. Okay. Now, how to get the key points. So if I sketch it using the points, I need to calculate what is x and what is y. Okay. So that will be in the second one here. So here he is telling me if you change it to uh, the Cartesian system, it's easier. So whenever I have x equal to sine 4 theta and y equals to cosine 4 theta, okay, since here sine squared of the angle plus cosine squared of same angle, in math 2 we said this is equal to 1. That will mean x squared plus y squared is equal to 1, and that is a unit circle centered at 0 and 0. So the graph will be 1, 1, and that will be 1 and 1. So the graph will be simply the unit circle, and as I said, to know the direction, we will select beta to be 0, and I will get the point sine 0 is 0, cosine 0 is 1, so that will be the point. When I select beta to be pi over 2, it will be sine pi over 2, it's 1, and cosine. When I substitute pi over 2 here, it will be, I have to know the delta. Delta, it's period over 4, and the period here 2 pi over 4, which is pi over 2, so that will be pi over 2 divided by 4, which is pi over what? 8. So when I substitute pi over 8, I will get, when I put pi over 8 here, sine pi over 2 will be 1, and cosine pi over 2 it will be uh, 0. So I'll get to this point, so it is anti-clockwise. That is if I select the Cartesian system. If I select the key points which I described in the first slide, our beta, we said our period, it's 2 pi divided by 4, which is pi over 2, and we say delta, it's period divided by 4, which is pi over 2 divided by 4, or pi over 2 times 1 over 4, which is pi over 8. So the key points is 0, then pi over 8, then 2 times pi over 8, 3 times pi over 8, and 4 times pi over 8, which is pi over 2, which is the complete period. So we will find the values of x, we will find the values of y, and the value of x will be, when I substitute 0 here, it will be 0, and here it will be 1. And when I substitute pi over 8, it will be pi over 8, which is 1 and 0. If I select pi over 4, it will be sine pi over 4, 0, cosine 4 times pi over 4 will be cosine pi, which is minus 1. 3 pi over 8, when I substitute 3 pi over 8, so it will be sine 4 times 3 pi over 8. So it will be 3 pi over 2, which is minus 1, 0. Sorry, 0 and minus 1. So this will be cosine, and that will be sine. So that will be, when we say, uh, when we say pi over 4, sine pi over 4 is 0, cosine pi over 4 is minus 1. Now that will be cosine, and that will be sine. So x will be minus 1, and y will be 0, because cosine is 0. At pi over 2, that will be sine is 0, and cosine 2 pi, it's 1. So now we put it in the xy plane. So we have 0 and 1, that's my star, then 1 and 0. So then 0 and minus 1, and minus 1, and so we have 0 and 1, 1 and 0, then 0 minus 1, minus 1, 0, then again 0 and 1. So we would 0, 1 go into this direction. So this is the direction of the circle. Wait a minute. We said when we put okay, probably here I have done a mistake. When I put theta is equal to 0, we will get x equal to, we will put sine 0, which is 0. So we will put y equal to cosine 0, which is 1. So when we start, we will get x is 0, y is 1, which is this point. When I put theta is equal to pi over 8, I'll get x sine pi 4 pi over 8, which is 1, and y will be 0. So that will be the point. So the direction is this one. Yes. Now, question number 16. Here we have, again, eliminate parametric equation to find the curve. So we have x equal to cosecant t, and y is equal to cotangent t. We know in math 2, 1 plus cotangent squared of t is equal to cosecant squared of t. So that will mean 1 plus, instead of cotangent, it will be y squared, is equal to what? Is equal to x squared, which means it is x squared minus y squared is equal to what? 1. This we call it hyperbolic, x squared over 1 squared minus y squared over 1 squared is equal to 1. And the best way to sketch the curve of this one, we draw first the basic rectangle where we have points. The center here, it is center is 0 and 0. And then we have A is equal to 1 and B is equal to 1. So from the center 0, we go 1 unit to the right and 1 unit to the left. Then we go 1 unit up from each direction and 1 unit down from each direction. So we get this fundamental rectangle. In this case, it is a square. So we will draw the diagonals, and the diagonal will be asymptotes for the graph. The vertex, it's here at 1 and 0, and there at -1 and 0. So the graph of this one, it will be that one. The graph here, it's that one. Okay, now that is the graph of this equation. If we now, now now, is this all of it? We will take it because we have restriction now here from 0 to by only. From 0 to by only, we will not have all the graph. The left-hand side here will be deleted because of the restriction in the domain. The domain here we have only from 0 to by, which means if I selected, okay, let me tell you why I have removed this one. In Math 1, sorry, in Math 2, STC says the following. Between 0 and pi, this is the angle 0, that's the angle what? Pi. Here, all of them is positive, and here only sign is positive. When we say sign positive, means cosecant also positive. So here we have, here x positive, our x here, it's positive, and our x also is positive because it's in the second quadrant. So our graph here in the first and second quadrant, and second quadrant, sine of t is positive, which means cosecant of t is positive. So because sine t and cosecant t is positive in the first quadrant and second quadrant, means we need to select x to be only positive. Here, this graph, x is not positive. Okay, so that's why we removed it. Okay, so our x is defined through cosecant t. So in this interval, 0 to pi, cosecant t is greater than 0, positive. In this quadrant, this is positive. So that's why we have to select our domain when cosecant is positive, means x is positive. So that's why we remove this left-hand side. Now, in which direction? Since we know the graph now from our Cartesian system, it will start at 1 and it will go that way and that way. We need only to select in which direction. So I will select just a few points when t, I have x equal to cosecant t, which means 1 over sine t, and y, it's cotangent t, which is cosine t divided by sine t. So I will select 2 points, of course, not sine equal to 0. So if I select t to be equal to pi over 2, what will happen for x? It will be 1 over sine pi over 2. Sine pi over 2, it's 1. And it will be cosine pi over 2, which is 0, over sine pi over 2, which is 1. So it will be 0 over 1, which is 0. So the point will be that point. So when t is equal to pi over 2, I'll get x is 1, y is 0. Now, when I, let's say, t to be pi over 4. T equals to pi over 4, I will get cosecant pi over 4, which is equal to x, it's root 2. And y will be equal to cotangent pi over 4, which is equal to 1. So it will be x is equal to, this is 1, so 1.4, and it will be 1. Okay, so the graph will have that direction. Now here is asking about in which direction sorry, what's describe the motion of this particle from pi over to 2 pi. So what we will do, we will say x minus 2, we have x equal to 2 plus sine t. So we'll say x minus 2 is equal to sine t. And I have y is equal to 1 plus 3 cosine t. So I'll say y minus 1 equals to 3 cosine t. So I'll divide by 3 here, divide by 3 there. So I will get sine squared t plus cosine squared t is equal to 1. That will mean x minus 2 all squared plus y minus 1 over 3 all squared is equal to 1, which means it's x minus 2 all squared over 1 squared plus y minus 1 all squared over 3 squared is equal to 1. Now, just 1 second, I'll take a call. Okay, let's continue. Now, where is it? Okay, so we said that is now we have in Cartesian system we get an ellipse. The graph of the ellipse is easy to graph. So we will say this is our xy coordinate system. We have here the center, it's 2 and 1. So this is 1, 2 and 1. And let me make it bigger. So I will say this is 1 and that is 2. So I'll say this is 1, that's 2 and 1. So the center, this is 2 and 1 is the center. Then I have below y 3, a is equal to 3. Below x, b is equal to 1. So from the center, I will go vertically in the y direction 3 units. So that will be 1, 2, 3. That will be the end point of the major axis. 1, 2, 3, and the 3 points below, and 1 unit to the right, 1 unit to the left. So that will be basically the graph supposed to be. This should be the graph. Okay, now does it go through all the cycle? If we have t is equal to pi over 2 until 2 pi, we will say no, it will not take all the cycle. When I select t to be 0, what I will get x, sine 0 is 0, so I'll get 2. What I will get y, y will be cosine 0, it's 1, so it will be 4. 2 and 4. This is x is 1, 2, and that will be 1, 2, 3, 4, starting from here. So that is the starting point where t is 0. You will get x is equal to 2 and y equal to 4. Now, when t is equal to pi over 2, what will happen to x? It will be x equal to 2 plus sine pi over 2, which is 2 plus 1, so it will be 3, and y will be 1 plus 3 cosine pi over 2, so that will be y equals to 1. So it will be, this is 1, 2, 3, and 1, so it will move this way. Okay, it will end up where? It will end up at 2 pi when t is equal to 2 pi. So when t, this is 0 pi over 2. Now I will not say, if it is, if I say pi here, what will happen? If I put t is equal to pi, definitely we will get this point, but at pi, sine pi as 0, so that will be 2, and when we put here pi, it will be 1 minus, sorry, when we say pi, it will be 0. When we put pi, we will get 1 plus 3 cosine pi. So that will be minus 2. 1 minus 3, which is minus 2, which is this point. Okay. Now, when I put 3 pi over 2, when I put 3 pi over 2, what will happen to the curve? At 3 pi over 2, okay, at 3 pi over 2, we will have x equal to 2 plus sine 3 pi over 2. Sine 3 pi over 2 will be minus 1, so it will be 2 minus 1, which is 1. And y, it will be 1 plus 3 cosine 3 pi over 2, that will be 0, so it will be 1, which is 1, and it will be, sorry, 1 and 1, which is this point. So it will move that way to this point. That is at 3 pi over 2. Okay, and let me see. Okay, the motion of particles and the motion takes place on the center of one. It goes from 1 equal to 2 pi. The particle at going to 3 1 started at 3 1 and starts at 3. It will start, it's not at oh, I started from, by mistake, I started from 0, but here this one, it says starting from pi over 2, so that's not our start. Our start is here, that's the start, which is at 3 and 1, because our interval starting not from 0, starting from pi over 2, and of course it will end up at 2 pi at this point. So we describe the motion is this one. The particle moves around the ellipse, starting from the point 3, 1, and ending at 2 and 4. The journey or the trip takes only 3/4 of the ellipse. Now, so let's say the journey takes only 3/4 of the ellipse. Okay. Now, the last question in this section, describe the motion of the particle. Now, it says describe the motion. Again, I will change it to first Cartesian system. I have x equal to 5 sine t and y is equal to 2 cosine t. So I will say here sine t is x divided by 5 and cosine t it's y divided by 2. From here we'll get sine squared plus cosine squared is equal to 1, so it will be x over 5 all squared plus y over 2 all squared is equal to 1, so it will be x squared over 5 squared plus y squared over 2 squared is equal to 1. Again, this is an ellipse centered at 0 and 0, and I have 5 below x, so I have to move 5 units, 1, 2, 3, 4, 5 units to the right, and 5 units to the left, 1, 2, 3, 4, 5 units to the left, 2 units up, 1, 2, and 2 units down. But basically, that's the graph in Cartesian system, but we are restricted according to t. It's between minus pi to 5 pi. Okay? Now, that could be more than one cycle. So it will start. First of all, our journey will start at minus pi. Okay? So when t is equal to minus pi, when t is equal to minus pi, what will be x? What will be y? Remember here before we start, the period, which means complete cycle, will be 2 pi divided by b. So it will be 2 pi divided by 1, which is 2 pi. So the complete cycle will occur after 2 pi from the start. We started at minus pi, so we are expecting, before we start, we are expecting the cycle will complete after 2 pi, so minus pi plus 2 pi, it will be pi. So we are expecting uh, at pi, so uh, this will be minus pi, then minus pi over 2, then 0, then pi over 2, then pi. This will be a complete cycle. Then when we started again, pi plus pi over 2 will be 3 pi over 2. Then so we say 0 pi over 2 pi, 3 pi over 2, then 2 pi, then after 2 pi it will be add pi over 2, 5 pi over 2, 6 pi over 2, which is a 3 pi over 2, sorry, it will be 3 pi, 3 pi, then 3 pi plus pi over 2, that will be 7 pi over 2. And anyway, what I want to say, we are not going to graph it, but I need to know how many cycles. So from minus pi to 5 pi, we said from minus pi until pi, that one cycle. Then from pi, again add 2 pi, so at 3 pi, it will be another cycle. And from 3 pi, add 2 pi, you will get 5 pi. So again, so here one cycle, and here is one cycle, and here is one cycle, so it will be 3 cycles. So we will start from where? When we put minus pi, I'll get here 0, and here I will get cosine pi, it will be minus 2. Minus 1 times 2, which is minus 2. So we will start at 0 and minus 2, which is, this is our starting point. We'll go to which direction? If we put minus pi over 2, that will be, if we put minus pi over 2, sine minus pi over 2, it's minus 1, so that will be minus 5, which is this point. Okay, and y will be 0. So we will start from here. When t is equal to minus pi, we will go to this direction, and we will complete the cycle. How many times? 3 times. So it will be the description of the motion. Particle moves 3 cycles, starting from the point 0 and minus 2. So it is a 3 cycles clockwise. This will end up our discussion. So sometimes it's easier to use the changing to Cartesian system rather than using the table, but we have to know, is it a complete cycle or 2 cycles or 3 cycles, or simply half a cycle or a quarter of a cycle. Okay, that is extremely important. Question number 26 and 27. It's extremely important sections because it's application, and it shows if you know how many cycles we have moved. So according to the periods, according to our interval which is given to us. Okay, that will be the first section which is section 10.1.